Okay, this is a response to the question that TJ was asked in his latest video. I couldn't think of any other thing to do, so here we go. Y is a minus times a minus a positive. Well, to start off, we'll make a couple basic assumptions that do apply to real numbers. We'll assume the additive inverse axiom. There exists a number such that a plus minus a equals 0. We'll assume multiplicative identity. 1 times a equals a. We'll assume the commutivity of multiplication. A times 1 equals a. Now, we also know, because minus a exists, minus a times 1 is going to equal minus a, and 1 times minus a equals minus a. We also know from additive inverse that 1 plus minus 1 equals 0. Well, a times minus 1 equals a times the quantity 1 minus 1 minus 1, and by distribution, a times 1 plus minus 1 times a plus minus 1 times a. So, a times 1 plus minus 1 times a must equal 0. Therefore, a plus minus 1 times a equals 0. So, minus 1 times a must equal minus a. Therefore, we can say minus a times a equals minus 1 times a, or minus a squared. Therefore, we can move on saying that minus a times the quantity a minus a is equivalent to minus a times minus a, and by distribution is also equivalent to minus a times a plus minus a times a plus minus a times minus a plus minus a times minus a. Therefore, minus a times a plus minus a times minus a is 0. So we know that minus 1 times a plus minus 1 times a times minus 1 times a is 0. Therefore, we know minus a squared plus minus 1 times a times minus 1 times a equals 0. Therefore, minus a squared plus minus 1 times a squared is 0. So minus 1 plus minus 1 times minus 1 must equal 0. Therefore, minus 1 times minus 1 equals 1. And because you can factor out minus 1s wherever you see minus signs, as we proved earlier, you can conclusively state that any time that you have a minus multiplied by a minus, you can factor out the minus 1s and multiply them through, and a minus 1 times a minus 1 will give you a 1. Therefore, eliminating the minus signs. So, this is why a minus times a minus gives you a positive, for those who are inclined toward formal mathematics.